What is going on, Bobcat Math family? This is your favorite tutor, Armand Houston, and in this video, we're going to take a look at the complex fraction that you see on your screen. Of course, the question is, how are we going to do it? So first, we'll factor all of the polynomial terms. Second, we'll find a common denominator between the terms. Third, we'll divide out the common factors. And finally, we'll express the complex fraction in its simplified form. Let's get started. All right, let's start factoring. Are you ready? Of course you are. So let's start with the numerator and move to the denominator of this thing. We'll start with x squared minus 9. So to rewrite this in factored form, we'll use the difference of squares formula, x plus 3 times x minus 3. On a side note, if you'd like a refresher on how this works, you can check out our short video on the difference of two squares. You'll find the thumbnail linked at the end of this lesson. Now, let's factor the next one, x squared minus x minus 6. We'll assume it can be written in some factorable form, x plus a times x plus b, for some numbers a and b. When we expand it, we can see that the sum of a plus b is the coefficient of x, and the product a times b represents the constant term. Comparing this with our expression, we can see that the product a times b is equal to minus 6, and the sum a plus b is equal to minus 1. We have two numbers that fit perfectly. A is equal to minus 3, and b is equal to 2. So we get x squared minus x minus 6 is equal to x minus 3 times x plus 2. Finally, we have x squared minus 4. But that's just the difference of two squares. So we have x plus 2 times x minus 2. And there we have it. All three factored and ready to go. So we've still got a little cleaning up to do, but that's okay. We'll interchange the previous expressions with the factored ones, and then simplify what we can and find a common denominator between the rational terms after that. Let's start by dividing out the factor x minus 3 in the numerator of the complex fraction. After we do that, we're left with the rational term x plus 3 over x plus 2. Now, we'll rewrite the complex fraction and take a gander at the denominators of the rational terms as we work toward finding a common denominator. If we look at the rational term in the numerator, the one above the large vinculum, we see that it contains the factor x plus 2. The rational term below it contains this factor as well, so we'll need to include x minus 2 in our common denominator to account for its absence in the term above. That gives us a common denominator of x plus 2 times x minus 2. Now, we'll multiply both the numerator and denominator of the complex fraction by this product. When we do, it sets us up nicely to begin canceling out common factors. But before we simplify this thing, I'll mention a quick alternative approach. If you have an appetite for variety, you can simplify this same problem by multiplying the numerator of the complex fraction by the reciprocal of its denominator. I'll put a thumbnail at the end of this video that links to a short demo showing that version, for those of you who'd like to explore it. So what do we do now? We tell cheesy math jokes. What did the factors in the numerator say to the factors in the denominator? We can't afford to be canceled. All right, looks like our factors can't dodge cancellation after all. But hey, that is great news for us because this is where we can finally start to clean things up. We can cancel the factor x plus 2 in the numerator of this behemoth. And we can also divide out both x plus 2 and x minus 2 in the denominator. What remains now is the rational expression, x minus 2 times x plus 3 over x plus 3. And our fraction is starting to look a lot better. From here, we can cancel x plus 3 from both the numerator and denominator. And just like that, the clutter's gone. That leaves us with the expression x minus 2. Nice and neat. And with that, my friends, we are finished. If you like this video, do us a favor, like and subscribe. Thanks for learning with Bobcat Math. This is Armand Houston signing off, and I'll see y'all next time.